Today we'll be solving question number 5. This is from May-June 2024 and this is paper 1-2 for CIE A-level CS. Okay, so this question is about assembly language. It's honestly a fairly straightforward question. If you'd ask me, this is a question in which is pretty much dependent on learning to read the question properly and get the answer done. The answer literally is within the question. Now I hope that you guys are already aware of this fact that in our assembly language questions we are given a table just like this one, and what we have to do is we need to be able to understand what each one of these things in the table are saying and then solve the given part. Alright, so we're given this. It says the current contents of memory are shown. So this is memory address data shown to us. This is the accumulator and this is the index register that's given to us. Now it says complete the table writing contents of the accumulator after each program has run. So first thing first, the first program is LDI. Now, I hope you guys already remember, but if not, we can quickly go back and see that LDI actually stands for indirect address, which means that it says the address to be used is at the given address. So the address is at the given address, guys. It's sort of like a double address we're talking about over here. You know, it's like when I'm referring to let's say particular address, this, so for instance LDI 15 is not the address. 15 contains something that has the address. So I'll go to 15, so it says the address to be used is at the given address. So the address to be used is at the given address, so 16 is the address, so I'll go to 16. Alright, and it says that load the contents of this second address to accumulator. So I load whatever is at 16 to accumulator. So if I do that, I know my accumulator is going to become 12 because 12 is at 16. So remember, it's a double address sort of a situation. Then it says subtract 1. Subtracting 1 simply makes 11. So the contents of the accumulator are going to become 11. Alright, now the next is LDD. Now if I go back, LDD stands for direct addressing. It means this time around we don't have any directions or something like that. I'm just going to go on and load the content. So it says load the contents of the location of the given address to the accumulator. So LDD 14, so what is that 14? So at 14 I've got 10. So I'm going to say accumulator equals 10 and it says add 11. Now please be careful about this. I believe we are already aware of this, that add or any other value is a matter of fact, instruction is a matter of fact, they are either with hash or without hash. This is without hash, which means it's an address. So basically this is what it's talking about. It says add the contents of the given address to the accumulator. So the contents of the address, alright, not the value itself. Because we do remember, I hope that in memory we've got address and data separately. So add 11, which means I'll go to 11 and I'll see the data that's 11, which is 3. So it's going to add this to it, so I'll get 13. So I'm going to have 13 over here. Now let's do the same for the next one. Now it says LDM hash 11. I just referred to this thing, that with the hash we generally have an exact value, which means I need to use that particular value. So when I say I have LDM hash n, this is stated right here, this is immediate addressing, which means that number will be loaded to the accumulator. So for this case I'll have 11 loaded to the accumulator. Then it says add hash 3, just like what I just mentioned, it's with the hash, so I'll just add 3, so that makes 14. And now it says subtract 16. Now think for a moment, will I subtract the value 16 or will I subtract what is at the address 16? Well, I hope you know the answer, that I will subtract what's at 16 because this is an address. How do I know? There is no hash with it. So I'll go to 16, 16 has 12. So I'm going to subtract 16 from it and I'm going to get an answer of 2. So I get 2 over here. Lastly, it's LDR. LDR is the fourth addressing mode in this case, which says it's immediate addressing, load the number n to index register. Now in this case what I'm doing is I'm loading this number to the index register. I just mentioned when I was starting off that there are two registers that are given, which have been talked about here, the accumulator and the index register. So LDR hash 2, again since it's a hash, so IX is going to hold the value of 2. Now it says LDX 14, another addressing mode that we have here, index addressing. From the address from address plus the contents of the register. Now it says from the address, from address plus contents of the index register. So whatever my base address is, which is 14 in this case, so what I'll do is I'll say 14. So my address is going to be equal to address plus the contents of the index register. So in this case it's going to be 14 plus 2, which gives me 16. So my address is 16. So then it says copy the contents of this calculated address to accumulator. So I'm going to go back to 16. 16 again is 12. So my accumulator is going to store 12, and then it says add 2 to it. So if I add 2 to that, it gives me 14. Apologies, I don't have the best handwriting, but I hope it makes sense. All right, now the next set of questions, again very similar to what we just did. I mean, the goal or the real way of actually solving this is that you need to be able to read this table. You need to be able to read the whole table and make sense out of it. Alright, now in this case it says bit manipulation instructions are given, which means each one of them explaining what happens when I use each one of them. And it says the contents of the accumulator are shown. Now this is the accumulator is shown to me. Complete the table by writing the content of the ACC after each program has run. The binary number is reloaded before each program is run. Now very important, sometimes you do struggle, and that's what I keep on saying, please make sure you read the question properly. It says 0110 is reloaded, which means every time I'll start with this and implement each one of the program from the beginning. It's not like I'm going to continue from the answer that I got for the previous step. Anyway, it says XOR 29. XOR 29. Now then again, if I go back up on XOR, I've got two forms of XOR. XOR with the exact number, which was the hash or an AND or a BN, which means binary. This is stated here, by the way, binary, hash and hexadecimal, or it could be an address. In this case it's an address. So what I'll do is I'll actually go to 29. So I go to address number 29. This has the value 4 zeros and 4 ones. So let me do this. So I'm gonna write it here. So the contents of the accumulator currently are 0 1 0 0 0 1 1 0, and the contents of 29 are 4 zeros and 4 ones. Yeah, so it's 1 2 3 4 1 2 3 4. Now when I'm going to XOR them, remember, I believe you do remember what XOR does. XOR gives me a 1 if and only if both are different. If both are ones or both are zeros, I get a 0. But if both my inputs are different, I'll get a 1. So 0 1 gives me a 1, 1 1 is a 0, another 0, 0 1 gives me a 1, 0 0 1 and 0. So the contents that I'm going to get, it's going to be 0 1 0 0 1 0 0 1. Alright, and the second thing what I have, it says that I am ANDing. So I'm gonna, in this case it says you'll AND with 29, and will I AND with the address, so the content of the address 29 or the number 29? It will be number 29. Remember, it has a hash. And yeah, if I go here, I do know again from my instructions as well, everything's given that it's going to be AND with the number 29. So let's go on and do this. So maybe let's write this over here. So I have 0 1 0 0 0 1 1 0. This is what the accumulator was. And if I go to AND hash 29, that means I will AND with the number 29. Let's real quickly find the binary for 29. Let's do this. 128 64 32 16 8 4 2 1. And if I'm going to find it, it's going to be 0 0 0 1 1 24 28 and 29. So it's going to be 0 0 0 1 1 1 0 1, and I'm ANDing, and I believe AND is probably the easiest ones. The output is 1 if and only if both of them are 1. So it's going to be 0 0 1 0 0 0 0 0. So for this I'm going to get 0 0 0 0 0 1 0 0. Alright, very good. And the next one says I'm ORing with B111. Now again, like I said, since probably the 100th time by now, everything it's in the table. So B11 means that I'm just ORing with the binary. You see over here it tells me that whatever is with B is basically just a binary number. However, I honestly don't need to solve this. If I was there, I would know that if you OR anything with 1, the answer will automatically be 1. I hope you guys have studied this, that we know this trick already. But still, let me solve it for your case. 1 0 0 0 1 1 0, and I'm ORing it with all 1, so 1 1 1 1 1 1 1 1, and OR gives me a 1, if both are 1s or any one is 1. Since I have at least 1 I know in each case, so my answer is going to be 1 1 1 1 1 1 1. So I'm going to write down 1 1 1 1 1 1 1 1. All right, I hope that makes sense. Thank you.